now we're looking at our velocity time graph. So before we are looking at our distance time graph. Now, the very front of this note package helps to give a summary of what's what. So when we look at the slope of a distance time graph, what does it give us? Slope of distance time gives us velocity. Okay. But then the area of a velocity time graph gives us distance. Okay, so it's different. So you're going to have questions after this lesson where you need to be able to say what's the slope gives me velocity, but on a different graph the area gives me distance, so that you can practice that. Okay, so if you get confused, this is a good summary of what graph to find what at. Okay? Alrighty then. Okay, so our velocity time graph. The object is initially traveling south. Okay? So anytime it changes direction, it's probably going to be going
the other way.
Yeah, no worries. Okay. Alright, let's kind of just figure things out here. I would call this A1, area 1. Here's my area 2. And here's area 3. Now, who remembers how we can tell if something changes direction on a velocity time graph? It's on the front of here if you can't remember.
Drop below the x-axis.
Okay, draw it below the x-axis. So, here, there's a change in direction. Because I was at the top of the axis and now I'm below. So, this is at time, what? There's 200, 220, 240 seconds. Where is my other change in direction? Here's 300, 320, 340, here's 360. Okay, how do I tell if something is at rest on a velocity time graph? If you can't remember, you can go to the front. Object at rest when graph is on the x-axis. So, when am I on the x-axis? From here to here. And here to here. So, I can say from 90 seconds to 150 seconds, and from 300 seconds to 360 seconds. What is the velocity of the object at 180 seconds? So I can go to 180 and identify what is the velocity at that point. So 180 would be right there. What is my velocity? 6 point, what do you say? 6.8. 6.8 meters. This is V with an arrow. So what else do I need to include?
Per second.
Yeah, thank you. Meters per second. And? South. The direction. I mean 6.8. Thanks, Lisa. Why did I put 3? Good, thank you. Does everyone get that? I wrote a mistake. It's 6.8 meters per second south. Yes?
Oh.
Moving on.
From 6.8.
What?
Nothing.
Okay. All right. What is the total displacement traveled by the object from 0 to 300? Okay, so what do I know about displacement on an area or on a velocity time graph? How do I find displacement? It's the area. Good. Okay. So I'm going to write my note to myself. That's the area. What else do I know about displacement? Is it scalar or vector? Vector. Wow, that doesn't even look like words. Okay. So, I need to find my area total equals area 1 plus area 2 plus area 3. That's why when we were first starting, we wrote in what our different areas were. Okay, so then my area total is equal to my length 1 times width 1 plus length 2 times width 2 plus length 3 times width 3. Now I'd encourage you to draw your L's like cursive looking, because if you just draw an L like straight as a line, it starts to kind of look like a 1, and just when you start writing so many things, it's a lot. So try and draw your L's cursive. Okay, so my area total is 90 seconds times by 5 meters per second plus my 240 second minus 150 seconds times by 6.8 meters per second plus 300 seconds minus 240 seconds times by negative 3.2 meters per second. So if you put it all into your calculator, you can. You just have to do it like make sure that you put enough brackets together so that you want to take this whole chunk and add it to this whole chunk and add it to this whole chunk. But I would recommend that you do your multiplication of each chunk first, which would give us 450 meters plus 612 meters plus negative 192 meters. How did I know that this one was negative? It's in A3. Look back at your graph. How do I know that's negative? It's going the opposite direction, and it's actually on the graph it's physically negative. So after I've changed direction, now my velocity as a vector, I need to put negative to symbolize it's going in the opposite direction. So my area total then is equal to 870 meters. So now I can say, well, that's my area total. That is equivalent to displacement. So D with an arrow over it equals 870 meters. Since this is positive and my initial direction is south, I know that it's south. Do you see how this is an exception to the positive-negative rule with north-south? Because this graph said it's initially traveling south. So then I say, and then the graph shows that it's positive initially, So then I say south is positive for this example specifically. Okay? So that's how there can be sometimes an exception with our north-south, is if the question specifically says initially it's south and initially it's positive. What is the average speed of the object from 0 to 300? So I know, okay, average speed, this is a scalar quantity, and my formula for this is V average equals D total divided by T total. Now, I'm not going to write out my distances all over again. I just figured them out from the previous question. So I know my distance is going to be 450 meters plus 612 meters plus 192 meters. Okay. Before, I had this as a negative. Why am I not having it as a negative now? Because it's just distance, it's not displacement. I'm only concerned about how far it is, not what direction, so I'm not including that it's negative in terms of changing direction. All divided by 300 seconds is how long it went. So this is equivalent to 1,254 meters divided by 300 seconds is equal to 4.18 meters per second. So then in conclusion, my V average is equal to how many sig digs do I have? Oh, it says record your answer to 2 sig digs. 4.2 meters per second.